Hello everyone, so today we're going to go over section 2.1, horizontal and vertical translations. So translations are transformations of graphs where we shift or slide all points of the graph up, down, left, or right without changing its shape or the orientation of the graph. We'll begin with vertical translation. So for any function y equals f of x and a d value that's greater than 0, so it's just any real number, the graph of y equals f of x plus d is the same graph moved d units up, and then y equals f of x minus d is the same graph, but move d units down. So an example of this would be y equals to x squared, which of course is the standard parabola. And if we compare that to, let's say, y equals to x squared plus 4, the second graph would have moved 4 units up. Okay. So a second piece of this is notice that if we begin with y equals to x squared plus 4, that is the same as y minus 4 equals x squared. Just going to write that out. So this statement here kind of just generalized that result. Um, and the reason why we want to do that sometimes is is for formatting more than anything else. So we can also think about functions as mapping. So let's say, for example, the point PQ is on y equals f of x, and that is to say that Q is equal to f of P, then if we compare that to y equals f of x plus d, then then we have y equals to f of P plus d, which is Q plus d. So if the point PQ is on the original function, then the point P Q plus D will be on the new function. Okay, so let's look at some example with graphs. So this would make a little more sense. So on the left, this is just a piecewise function. On the right is the same one. So you might notice right away, we notice right away that this graph is up 3 spaces, right, because of the plus 3 here. So essentially, what we can do is simply plot all the points 3 spaces up. So start here, 1, 2, 3, 4, 5. Those are the original points on the graph. And we can simply move them each 3 spaces up. So let's use a different color. So 1, 2, 3, 4, and 5. And it will simply connect these together. So if this was done correctly, the graphs will have the same shape, just a new location of 3 spaces up. Okay. So likewise, on the right-hand side, notice that y plus 4 equals f of x is the same as y equals to f of x minus 4. So that means this negative 4 here means we move the graph down 4 spaces. So again, the same thing. So 1, 2, 3, 4, and 5. So the 5 points. Let's connect them together. that's all we need to do. Actually, I think it asks for the domain range. Oh, yes, it does. Okay, so the original function, the domain and range of this function, let's just write them out. The domain goes from -4 to +5. And the range of this function is from -3 to 2. Okay, so what we'll notice is that the domain of the transformed graphs are the same. The domain is still from -4 to +5. What changes is the range, which makes sense because the only thing that we did was we moved the graph up or down. So the new range on the graph on the left is 0 to 5. And on the right, we have -7 to -2. Okay. A translated graph is then congruent to the original, is the same size and shape. Okay. Let's look at some examples. So here, we have y plus 5 equals f of x. That means the graph was moved down 5 spaces. And on the right, example B, this is up 2 because of the +2 after the f of x. Okay. Similarly, it's the same question, but worded slightly differently here. What happens to the graph of f of x if the following changes were made? So an easy way to do this is just replace y with y minus 8 as per the instruction. So this would be up 8 spaces. And this one is new, so if we replace x with x plus 2, see what happens here. Notice that the +2 is inside the parentheses of the function, so it doesn't move the graph up or down, it actually moves it left or right. So thinking back to what we saw, if y replaced with y minus 8, as we had on the left-hand side here, actually moves the graph up 8 spaces. It would make sense that if we replace x with x plus 2, that this actually moves the graph in the negative direction as it moves left 2. Okay, so it's a little bit different. Right, because when we replace y with y minus 8, the graph moves in the positive direction of y, which is up. So if we replace x with x plus 2, the opposite will happen. So we move the graph in the negative direction horizontally, and that results in moving the graph left 2 spaces. Okay, so the following box, horizontal translation for any function y equals f of x and c is greater than 0. Y equals f of x minus c moves the graph to the right. Y equals f of x plus c moves the graph to the left. Okay. Just as a side note here as well, thinking in terms of mapping that we saw on page 1, if PQ was on the original graph, then this transformation will give us the point P plus C and then Q. So the whole graph moves to the right. Likewise, in the second case, if the original function had a point PQ, then the new point would be P minus CQ. All right, so let's look at a couple of graphs as an example. Example number 2. See what happens here. So again, we began by looking at the transformation that would happen. The translation that would happen in this case is right 2. And on the right-hand side, we have left 4. So simply move the points to the right 2 spaces. Then connect them together. So we'll get a congruent graph, just move to the right 2 spaces. And on the second example, left 4. So 1, 2, 3, 4. Right, so the second graph will look like this. Okay, let's look at the domain and range of the original function and then the new transform graphs. So domain here was -3 to 4. Sorry, -3 to +4. And the range was -1 to 3. And after moving the graph 2 spaces to the right, the domain is what changes in this case. So we have -1 and then +6, but the range remains the same. And likewise for the second example on the right-hand side, the domain was, excuse me, 1 to 4. And the range was -2 to 4. And after the transformation, the domain is what changes. It was moved left 4 spaces, so we get a domain of -3 to 0. Okay, notice that each one of the values in the original domain here, these two values, they were each subtracted by 4 to get the new domain. And of course, because there's no vertical translation, the range stays the same. It will still be -2, 4. Okay, so moving on. Again, very similar kind of questions here. If y equals f of x was replaced by y equals f of x minus 7, this moves the graph right 7 spaces. And on the second example, this would, of course, be left 6 spaces. Okay, and finally, if we are given the translations instead, we want to write y equals g of x after the transformation. Let's do this quickly here. 3 units to the right, so that would be y equals to g of x minus 3. Second one, 8 units down, so y equals to g of x and then minus 8. 9 units up, y equals to g of x and then plus 9. And finally, a new type of question. We can actually, of course, combine the horizontal translation and the vertical translation. So we have y equals to, in this case, left 7 spaces, so g of x plus 7. And then 2 units up, so this would be plus 2 outside of the parentheses. Okay. So that's why we chose different letters for horizontal and vertical translation. Usually D denotes the vertical translation and C denotes the horizontal translation. And we set the letters A and B, and they are going to be for different transformations as well. Okay, so let's look at combining horizontal and vertical translations. So first one here, instead of y equals f of x, we have y plus 2 and then f of x minus 3. So transformations here will be right 3 and down 2. So we'll take each of the points of the graph, move 3 spaces to the right and down 2 spaces, like so, and then connect them together. Again, we'll have a congruent graph in a new location. Okay. And on the right-hand side, we have a parabola. So for the first time, we have a kind of explicit function. Instead of just f of x, we have y equals x squared. So this is different, but it kind of works the same way. And that is to say that this graph, this part here, x plus 1 means the graph moves left 1, and the plus 4 here moves the graph up 4 spaces. Okay, so let's go ahead and plot some of the new points. Okay, then do my best to draw a parabola. That's it. So let's look at the domain range of the final graphs. So domain here would be 0 to 7. And the range is from -3 to +1. Oh, sorry. Function of the right, the domain x is an element of the real numbers, and the range y is greater than or equal to 4. Righty. So let's see what other questions are possible in regards to translations. It says here, the point A with coordinates 3, 7 lies on the graph y equals f of x. What are the coordinates of its image A prime on the graph of y equals f of x plus 3 and then -2? So, be a good idea to identify the translations. The plus 3 here means left 3, and then the -2 means down 2. So the point A prime would have coordinates, let's see, 3, left 3 spaces means -3, and 7 down 2 means -2. So A prime would have the coordinates 0, 5. Okay, let's keep going here. Let's look at example number 3. The graph y equals x cubed is translated to the right, 2 units to the right and 1 unit down. What's the equation of the image graph? Okay. So, a good idea to think about it as just y equals f of x, and then those two translations, that will give us f of x minus 2, 2 units to the right, and then 1 down, minus 1. And then we'll try to fit it back with y equals x cubed. So we'll have y equals 2 x minus 2 cubed. We replace x with x minus 2, so all of x minus 2 will be cubed here. And then minus 1 will be outside the parentheses. Just 1 unit down, sorry. Struggling writing 1. There we go. So that's all that needed to be done. We could expand the x minus 2 cubed by multiplying it out, but that doesn't seem necessary in this case, so we'll leave y equals to x minus 2 cubed minus 1 as our final answer. Okay, last one for today, very similar kind of question. The graph y equals to the square root of 25 minus x is translated 3 units left and 2 units up. What's the equation of the image graph? Alright, so that means, so another way to think about this is we are replacing x with x plus 3 because of the translation to the left. And here, we're replacing y with y minus 2. Okay, so what will happen is then we have y, instead of y, we have y minus 2. And then we have the 25. And instead of minus x, we have minus x plus 3 because of the replacement. And then we can now add in the square root. Okay, go ahead and simplify this a little bit. So of course, the 2 can be added to the right-hand side of this expression. And the terms underneath the square root sign can be simplified a little bit as well. So we end up with y equals to 22 minus x would be left under the square root sign. And then just outside of it, the minus 2. Oh, sorry, not minus 2, plus 2, because we added 2 to both sides. That's better. All right, so that's it for today. We looked at translations of functions, up, down, left, and right. Those are the key ones, and how they affect the equations of those functions. Again, that's it for today. Thank you for listening.